Okay, so, okay, 32b, yes, these questions. Okay, so what can we do for these questions? Oh, it got modulus. It got modulus at denominator. So we can do it in simple form. We can do it in special case. So let's us revise our special case where have both side modulus inequalities. So this is inequality question that have both side modulus. So we can move our denominator to the right hand side in order to get both side modulus. So first of all, uh, x minus 3 greater than 1 times this modulus 2x minus 1. So we get both side modulus already. Okay, so bear in mind, be careful here, when we move our denominator to the right hand side, we always need to mention our denominator cannot equal to 0. Our x cannot take the value of 1 over 2. So later on, we need to take out this answer. We need to take out this answer. X cannot be 1 over 2. After that, okay, so we can go back to here. We can go back to this part when we have both side modulus inequalities. What can we do? We can rewrite our modulus in square root and square. So 1 times this, I didn't write the 1. It's same. It is same without writing the 1. So I change the symbol of modulus become the definition square root and square. So when we have square root both sides, we can solve this by square both sides. So when we square both sides, we can get this one is 4. 2 square is 4. And then for inside here, square root and square finish, we get x minus 3 square. Then this one square root and square cancel each other, we get 2x and 1 square, leaving x minus 3 square and 2x minus 1 square. So we're going to expand these questions 4. And then expand this, x square minus 6x plus 9. So remember our expansion here will be a square, 2ab, and then b square. So repeat for this right hand side, we expand, we will get 4x squared, then minus 4x plus 1. So expand some more, 4x squared. So is it we are getting quadratic? Is it we getting quadratic? But obviously when I move this quadratic, it will be minus off. So it will cancel each other, it becomes 0. Okay, so I move here, this one will become negative 28x. So it is, after we simplify, it is getting linear. It is getting linear because when I move this x squared to the left hand side, they cancel each other already. It don't have any x squared. So it become linear only. So when I want to solve our linear inequalities, we let the x, we move the x to the left hand side. So this one plus 4, negative 20, greater equal, the value I move to the right hand side here, minus. So minus 36, it will become negative 35. So we just simplify it by linear equation. We solve it to find the x. So when I want to divide this negative 20, so divide by negative 20, I need to, negative value, I need to change sign. So simplify it. This will become 7 over 4. Okay, so the question's answer will be, finally our answer will be x less than 7 over 4. And then don't forget, our x cannot take the value of 1 over 2. That will be our final answer. Okay, so now we look at the concept we need to alert here. So for the first part is when you simplify your denominator, you are changing the rational function to quadratic, right? So you have to maintain its originality of the question. Originality of the question is rational. So rational cannot take denominator 0. So this value is cannot fulfill these inequalities. So we have to mention out means basic. Basic, you have to mention out your value cannot equal to 1 over 2. And then when you want to solve this both side modulus, we are going to square both sides, right? So this is the concept we are going to see how you're going to expand and square both sides to get the answer. Expand correctly. Then finally, we after we simplify the question, we go back to linear. So concept of solving linear is move to the left, x to the left hand side, and then the rest of the value to the right hand side to get this answer. So finally, we have to combine our answer. Finally, we have to combine answer. We can get x less than say 1 over 4, but be careful, we won't take the value of 1 over 2. That will make this fraction become undefined.